Okay, sorry about that. It's kind of a long story in a nutshell. I need to work on a 10,000-year-old electronic cash register, but I really don't want to drive clear across town to tinker with it. It sounds like it's on its last leg, so that's why I'm kind of putting it on the back burner a little bit. Okay, so what did I do? I put my tools away because I thought I might use them. Okay, so where are we at here? What I'm going to do here is kind of straighten this old lead out. And see if it'll take some solder. Looks like I might get a burn on there, whether I want to or not. There we go. Dang it. See if I can tin this. These old leads are steel and they don't take to soldering too kindly. Dang it. Okay. Where did that go? Okie dokie. So I'm just going to fold that down, lay that up there, and make a little kind of a butt joint, or a lap joint for lack of a better word. Okay. Joint is about there we go. The joint's about, I don't know, it's I don't know, not 3/4 of an inch. I don't know, about 1/4 of an inch. I suppose technically yeah. Well, I don't know. I suppose technically I should have bent the leads over and hooked it together, but there's just not enough meat there. And despite what people think, solder is pretty strong. I don't know. We're going to call it good. Sometimes life is about compromises, and that's probably one of them. I just don't like those. I don't like those, you know, those hook joints. They just bug me. They look like hell. And they end up falling apart anyway. Personally, I think that lap joint is probably stronger. Okay. So we got the AVC resistor back in. What did I tell you that was? C3 PO. Yeah, okay. Okay. Now this one a little. The voltage on here is actually going to be negative. This is from the AVC. It comes off of that detector tube, and they feed that voltage back to knock the gain down of the tubes as the voltage comes up. So this is a negative voltage. So the stronger a station is, the more negative it is. Now this is a good point to look at for a couple different reasons. Our radio isn't going to come back to life till we do something, right? Well, how about we hook? We'll put the clip lead back on the. Back on the clock bypass channel there. Right there. And you're not going to see this terribly well, are you? Maybe the speaker needs to be hooked up too. Just having a heck of a time today. It's just one of those days. Okay. Well, you can't see that for... That's interesting one with that focus. Okay. Weird. Seem to have found some chink in the camera's armor there. How about that? Yeah, that's better. Okay, so we'll tune this.
Now anyone can actually, any bush as a small godly conservative without a smirk on his face is beyond. Warren, there was the church. He just welcomes them and talks to them and stand unresolved. I mean, I think Hillary will have it.
I don't pick the stations, I just tune them. So there you can see as the station comes in stronger, the meter, heads more negative. There it's almost 4 volts. We're on the scale right there under the mirror. That's like 3.8 volts. Now, this is a good time to notice something. This is a step that a lot of people forget about or just don't know about, I think. The AVC voltage is kind of important, and basically it comes out of that tube, goes through a pretty high impedance kind of circuit there. It's usually 2.2 megohms. There's a resistor there. Remember, that resistor was over here on this circuit. It's in the circuit diagram, if you're following along, it's R3. It's about in the middle of the page, under, kind of under V2. And that cap, basically that resistor and that cap form a little filter network. And supply that voltage back to the elements of the tubes to shut them down as the signal gets higher. Couple points of interest. If that cap is dried up, you'll get a couple potential things, and that's why you ought to look at this voltage. This one seems pretty steady. It's just kind of hanging in there. It's not moving around. This is me fooling with the antenna. Actually, I'm making it better. Wow, that thing's got a lot of AVC. If that voltage is fluttering, if that meter is fluttering back and forth, that could be a symptom of that cap being dried up or leaky a little bit. The other thing you could have happen too is if that cap is almost non-existent, you could have what's called blasting, where you tune the station and it just comes in louder than heck, and you're having a hard time tuning the low, distant stations. You can't hear them very well. So that test is important. A lot of people forget about that, and I see a lot of radios with that symptom kind of lurking around. It's a forgotten circuit. Okay, so we've got the radio recapped here. The only cap I did not redo is that little substrate cap, that kind of hybrid cap. One of the things I noticed about this radio is the audio output tube runs damn hot on this thing. I can actually feel it on the underside of this thing. And that's the rectifier tube, and this is the audio output tube, and you can feel the heat off of that thing. I kind of wonder if it isn't if maybe the bias is off on it a little bit. Which you can't see here. It's almost about 8 volts, and I believe the drawing says, if you look on the schematic on pin 1, it looks like about 6 volts. And that means there's a lot of voltage growing across there. One of the other things that would happen too, just kind of FYI, if you hook up to the plate, and the plate voltage, you don't have any audio, and the plate voltage is really high, that cathode resistor might be open. Well, there's something going on here. So if we look at the grid of that tube, which is pin 2, and it's right here. That's interesting. There is. Every day's a challenge. There's the meter zeroed out with no voltage, and I'm going to hook the voltmeter up to it. There is a little bit of voltage on there. It's pretty small. We're on the 1 volt scale. What is that? That's like 1/100th of a volt, maybe. It's pretty small. One of two things could be happening there. That 1 megohm resistor could be open. It would be right here, and that's R7. That's off of pin 2 of the output tube, or that cap that connects the output of the detector could be leaking. This little hybrid right there. You can't see it. It's a little hybrid substrate there. It has about 3 or 4 caps in it. Very interesting. Well, according to the drawing, that is 0.005 microfarad. That's what, 5,000 picofarad. Now, a quick test. Well, actually, a quick test would be to test that resistor, and we'll do that. So we'll get on the old ohm scale here. Sorry, this just isn't real conducive. And no, we need to zero that out. And we need to zero it the other way. Probably gonna have to go back and forth. This voltmeter has FETs in it. It's more like a VTVM than it is a Okay, so that's ground and that's well, resistor appears to be intact. That lead there is pretty easily accessible. You could do one of a couple things. We could just unsolder it and pull it out. We could clip it in half. I've done stuff like that before. I don't know. It's not. If you were in a hurry, that might be the expedient thing. I say we unsolder it. Now keep in mind that that voltage was pretty small. One of the other things we could do is we could ground that. That's what they're trying to do with that. They're trying to pull that to ground with that resistor and that cap. And we could just ground that with a jumper wire and see how much difference it makes. It may not make enough difference to really add up to a hill of beans. So what it just did there, that was a dumb move. Basically, I rotated that meter through its ranges while it was still plugged in. Now, the radio wasn't on, it didn't hurt anything, but if you were measuring DC and rotated through the ranges and wanted to measure AC, you would rotate through the ohm scale. You probably would damage some of the resistors, so that's kind of a no-no. That was a kind of a lapse lapse there. That was not cool. That's a mark against me. Okay, so I'm going to power the radio up and just see what we can get.
That's 402-453-5673. Now 10 years in Omaha, rated A+ by the Better Business.
So we've got about, that's interesting. Notice it's creeping. Huh, that's interesting. Very interesting. Oh, we will ground that. Won't hurt anything. It's in essence what you're doing. Okay, so we will pull that to ground temporarily. It didn't do a thing to it. Okay. Okay, so that isn't an issue. I don't know what that's about. The tube might be having some issues. Well, that tube seems to run pretty hot. That resistor could be thermally unstable, and I didn't measure it. That resistor's value goes up, shouldn't be a big issue. Just a little concerned. Although those tubes in those radios do run pretty darn warm. Leave a little skin behind, and they're usually pretty good. You get them warmed up, they usually sound pretty good. So that was 150 ohms. That's R8. It's right under the audio output tube, V6 or V4. V4. I got V6 from. Okay, 150 ohms. So we'll just test that. Well, looks like it's 150 ohms right on the net, so I guess. Well, you know what the other thing could be too. In the notes there, it says measure this with a what was it, 20K per ohm or per ohm volt voltmeter, and that voltmeter is more like it's like 10 megohms. So that probably is what's going on. Okay. So it's a little high. Well, I think as far as the capacitor row here goes, I think we're done. The only ones we didn't replace were this little ceramic, which is 47 picofarad, and this hybrid here, which is made up of 4 caps. It's a C9 like A that's on the grid of the detector tube before it hits the volume control. There's C9B, which goes in between the cathode of the detector, V3, and the pin 4 of the IF transformer there. There's C9C, which goes from the cathode to the plate, pin 7 and 2, and then there's a last one that goes from pin 7 of the detector tube to pin 2 of the power output tube, which is the one we'll be making. So there's 4 caps in there. Okay. Well, as far as capacitor row, looks like we're done. Interesting little point of interest. I've been eyeing this resistor. Now the drawing says it's 1,000 ohms at a few watts. It's kind of in line. That comes from this yellow lead, which goes through the audio transformer, kind of taps it there. That's how they get the secondary voltage, the lower of the 2 voltages. That's also where the junction of that filter cap's secondary cap is. So that's probably what, about 90 volts, somewhere around there, if I had to guess. Yeah. But here it looks like it's 22 K. It's orange and black. I don't know if that was replaced or if that was something that was bodged in there. I guess we could kind of measure it. The
Us today, but
yeah, looks like it's about 90. Wow. So one of those power supplies is about 115 volts, and this one is about 100. That's probably not out of the norm. And keep in mind, again, we've got this kind of high impedance voltmeter. Here's a little interesting trick. Find a ground. And hook your voltmeter up to one of the power supply rails, and you got it there. Okay, we're looking at, yeah, just a touch over 100 volts. Take and watch that while I turn the radio off. It took, what, about a second or two to drift down. I mean, you could see it run down. If you have a bad filter cap, that thing will just drop like a frickin' rock. Now, one of the other things you can do this with a fluke, but you can't do this with these voltmeters easily, is measure the ripple on the DC. On that first cap, you ought to see probably about 6 volts of ripple. Well, looks like there's about doodly squat there. But, make an assumption here. If you put a cap in series, it can be, this is like 0.05, and I'm under the impression that it's good. Oh, looky, there's some voltage there. And there's about, yeah, roughly about 5 volts of ripple. All I did was put this cap in series with that lead. What that does is blocks the DC component and lets the AC pass. These meters don't do too good with DC biases. But the meters like the Fluke, more modern digital meters, can ignore that, and you can get a good idea. And like I said, right out of that power supply's rectifier tube, that first cap, you probably see about 6 or 3 volts of ripple. Now on that second cap, on that secondary power supply, it probably is down in the tenths of a volt, and those meters won't dive down that far normally. I'm all for, some of the new modern digital voltmeters have some good features at a cost. You know, that's probably a $120 meter, Fluke voltmeter, where this other Micronta meter was $3. But with a couple little tricks, you can, extend the usefulness of your voltmeter. Now, keep in mind that your mileage may vary depending on the input impedance of your AC voltmeter. That one's pretty high. I bet I could get away with a pretty small cap. Yeah. Oof. So far, we've done some fun stuff. Guess we're going to have to kind of turn to the clock here and see what we can get going. Okay, take her easy. Have a good day.